The basic Bell-Lincoln framework for the cosmological model. The basic Bell-Lincoln framework is an approach to understanding the universe that is based on the idea of scientific realism. The basic Bell-Lincoln framework divides the universe into three parts. The first part is the physical world, which consists of all objects and phenomena that can be observed by humans. The second part is the mental world, which encompasses all of our thoughts and ideas about what exists in our physical world. The third part is a metaphysical realm, which includes all things that exist outside of our physical and mental worlds. We do not know what exists in this metaphysical realm, but it has been suggested to exist as a separate dimension or reality from ours. The experience of a fourth-dimensional being would be completely different from our three-dimensional experience. In the fourth dimension, one could see objects as if they were flat, for example. This is because the physical world would not exist in the way that it does in our third dimension. In the physical world, objects like trees and chairs would not exist as they are in our third dimension. There may also be other dimensions that are further from us than the fourth dimension, but not physically capable of being perceived by us. This alternate universe had three dimensions and also a fifth dimension, which was used by the artifact. The fifth-dimensional beings could move among any point in time and space without limitation. The mathematical concept of dimension describes the number of spatial dimensions. The number may be less than 4. There are different types of dimensions, including spatial and temporal. Temporal dimension is the number of times a physical event repeats in a period of time. A line has one spatial dimension and one temporal dimension. What are the differences between physical and cosmological models? The physical model is based on observation, and has a lot of empirical data to back it up. This type of observation gives us a lot of information about how Earth works, contrary to the cosmological model, which is based on theory. It uses theoretical concepts such as gravity and energy to explain how our universe works. For example, the cosmological model suggests that gravity is a fundamental property of our universe. We can't see what's beyond ours, so the only way we have to know our universe is that it exists and there are other universes out there. All the matter in the universe was initially compressed into a single point and then exploded outward. There are many other theories on how the universe might have formed, but this is currently the best explanation. The Big Bang Theory. 1. The universe was originally compressed into a single point. 2. The point exploded outward, giving birth to an expanding universe. 3. As the expanding universe cooled, atoms could form and gravity began to pull everything together. There are some stages that the Big Bang Theory includes. Inflation is the rapid expansion of space in front of the universe before it reached its critical point, Big Crunch. Epoch of ionization is the time when all hydrogen in the universe combined into neutral hydrogen, H. Cosmic background radiation. Cosmic background radiation is an electromagnetic radiation emitted by all parts of the universe that came about at the time of ionization. Cosmic microwave background radiation. This happened because of supernovas and other events that led to great light coming from different parts of the universe. When these events happened, it went towards what we now see as the cosmic microwave background radiation. The 5 most common misconceptions about the secret of the cosmological model in physics. The cosmological model is the theory that explains how the universe came into existence. It was developed by Albert Einstein and his colleagues in the early 20th century. This model is based on a set of 5 assumptions. 1. The universe must have had a beginning. This idea is at the heart of the Big Bang Theory, a debate that's been raging for decades. It's also at the heart of many religions and philosophical debates. It's an issue that has plagued philosophers for centuries. But what does science say about this question? First, it's important to know the difference between beginning and creation. The word beginning is used to describe what happened before something. Creation, on the other hand, is when something comes into being. So scientifically speaking, beginning isn't a question of time or number. What science asks is how something could have come into existence. 2. The universe is homogeneous and isotropic. These two terms mean similar in the sense that they are both used to describe a situation where there are many similar objects or events. It is believed that the universe is homogeneous because there is no way to find a particular spot on Earth where one can say that everything else is exactly like it. The universe is isotropic because it has only one fixed spatial orientation. All matter in the universe is made up of atoms. An atom is the smallest unit of a chemical element that cannot be split into two smaller units. All atoms are composed of three subatomic particles: protons, neutrons, and electrons. Protons have an electric charge of +1 and neutrons have no electric charge at all. Electrons have a negative charge. 3. The universe has a finite age, and will end in heat death. The universe, which consists of all the matter and energy in existence, is very old. The universe is expected to end in heat death when it no longer emits enough energy to counteract its own expansion. This will happen when the universe reaches a temperature of 2.7 Kelvin, 0 degrees Celsius or 273.15 degrees Fahrenheit, in 10,100 years. Life on Earth began about 3.8 billion years ago and is limited to the planet because of its size, gravity, and climate. Life on other planets is impossible. 4. The speed of light in vacuum is constant. Light is one of the most important and basic properties of our universe. It is often seen as a metaphor for truth, progress, and knowledge. The speed of light in vacuum is constant. The speed of light in a vacuum is about 300,000 kilometers per second. When measured from space, it should be 300,000 kilometers per second. The speed of light in vacuum drops to 129,988,548 of a meter per second when light passes through medium like water or glass. 5. In the universe, spacetime is flat. The universe is a very vast and complex place. Spacetime is the fourth dimension, which is hard to comprehend. The universe has been around for 13.8 billion years and it does not have any end in sight. It's difficult to imagine how long the universe has existed, let alone what it will look like in the future. It's also hard to imagine how many things exist in it. However, because space is such a large and complex place, there are some amazing facts that we can use to understand it better. The space we live in is actually really cold. Space is so vast and complex that it's hard to comprehend. If this is true, then what would the temperature be of a dark, starless void?